Okay. Considering the number of offices required for consultations, we need at least 25 computers, one for each doctor. So a 48-port switch will be necessary. The rest of the ports can be used to connect the access points required for the ground, so the patients can connect wirelessly. Considering the amount of 160 patients divided by the 4 floors in which patients can stay, we can estimate up to 40 patients per floor. If we assign one room for each patient, we need at least 40 little rooms. Consider that each floor has 1,500 square meters of space and that our access points have a range of 300 meters. We will need approximately 5 access points per floor, 30 access points in total to satisfy the demand. So another 24 port switch is going to be enough. The ports that are left can be used by the IT and administration departments so they can connect to their computers. The switches are going to be layer 2, since layer 3 offers routing, which is not necessary because we already have a router that is not as expensive as a switch layer 3. Since we have little traffic, just up to 350 users, one router can handle this. I will use only 2.4 GHz because I prefer more range with less speed, since people in hospitals don't require fast internet, since they use applications that require few download speeds, such as internet surfing. Also, doctors are not required to upload huge information, just text. Also, it's important that hospital equipment does not have any interference, so 5 GHz will generate a short range, so it's not necessary. The Cisco Catalyst 915 access point, which is the cheapest option based on the Cisco store, is perfect for entry-level implementation. It can support up to 200 devices and 1.2 GB per second of data transfer speed, perfect to satisfy the necessity of guests, such as basic internet surfing, chatting, etc. It will be perfect to use a lightweight, since we have an IT department that can administrate each access point, and a standalone will be more priced. As mentioned before, I will place them on each floor, at least 5. Since the hospital is small and the access points selected have an embedded wireless controller, the purchase of another component will not be necessary to satisfy the cost of the implementation. Yes, I will have 5 VLANs, so 5 VLANs will be necessary, one for directives and administration and IT department, which is going to be the trunk VLAN, allowing them to manage and configure the router, and another one for doctors, so it's going to be easier to manage the access to the servers with databases, another one for nurses, another for patients, and the last one for guests. The distribution will allow the IT department to control access to certain servers in our network. For routing, it's going to be preferred static routing because there is a single preferred route in our topology. And since a simple access list and a specific VLAN for doctors will help build a firewall to protect the server with important information, blocking patients, guests, and other people from accessing the information, there is not necessary any extra devices for security, because routers can block certain traffic and VLANs can help to determine which group has access to certain information. I will consider IPv6 with IPv4. I will consider IPv6 for this implementation, and with IPv4 we can satisfy the demand for the hospital, but IPv6 is gaining strength, and organizations like LACNIC are considering incentive companies to use IPv6. So I think it would be better to use IPv6 to be prepared when this change happens. Also, IPv6 will have more advantages, such as more IP assignations that will allow the hospital to implement eventually IoT technologies such as robotic surgery, which represents savings in salaries. Based on LACNIC, IPv6 they say it's becoming cheaper and faster, so to satisfy the demand of our hospital, it's going to be important to have IPv6 with no much cost. Since we have an estimate of 385 users, and IPv6 with a /119 subnet could be used to satisfy up to 510 hosts, so we still have plenty of IP addresses left.